Hi, welcome to the video solution for Edexcel Physics past paper. This is Edexcel IAL Physics Unit 3, October 2017. Let's start. Question number 1. Which of the following is SI base quantity? Not unit. They are asking about the base quantity. So again, a typical question between derived and base quantities. Base, you know that there are only 7 base quantities. So force is not a base, Newton cannot be a base, only these two are base. But ampere is a base unit and current is base quantity. So your option is C. Question number 2. A student measured the length as 2.74 meter. Which of the following is the uncertainty in this measurement? So these are the option, and if you see option A and option B and your given value, so your given or your measured length is 2.74, contain 2 decimal places, and option A and option B have 3 decimal places. So too many decimal places compared to the measured one. So you can ignore A and B immediately. You need to choose from C and D because both has 2 decimal places. But option D is 0.05, which has a high value. That's why we also ignore D. So our option must be C because of 2 decimal place and low uncertainty if you see the measurement. Question 3, 4 and 5 refers to the experiment described below. In an experiment to determine the viscosity of a liquid, a student releases a sphere from rest into the liquid in a tall measuring cylinder. The sphere reaches terminal velocity. She records the distance through which the sphere falls at a terminal velocity and the time taken. Okay. The time she records are 0.41, 0.43, 29 and 38. Which of the following should she use as the mean time in her calculation? Again, a typical question, finding the mean from the data set. And in this, generally, they want to check your concept of anomalous reading. So if you see 0.41, 0.43, 0.29, 0.38, so first two and the last one are close reading, but 0.29 you can say it is your anomalous reading, so you ignore this and you find the mean of these 3 numbers. Add these 3 and dividing by 3 you can get a mean. If you do 0.41 plus 0.43 plus 0.38 and divided by 3, so you will get 0.4066, round it off, so 0.41. Your option is D. Question number 4. Which of the following would be most suitable for measuring the distance in millimeter through which the sphere traveled? Measuring distance, the most suitable instrument or device is meter rule for measuring the distance in this experiment. So meter rule, because it has a precision of 0.1 centimeter. So most suitable meter rule, option A. Question number 5. Which of the following should she use to measure the diameter of the sphere? A small measurement, diameter of the sphere, and the most suitable is micrometer screw gauge. So option is B. Question number 6. A student plans to determine the resistance of an unknown resistor using a graphical method. Draw a suitable circuit diagram for the experiment, including a voltmeter and ammeter and any other necessary apparatus. So in this experiment, you need to find unknown resistance, which is this rectangular box. This is unknown resistor you need to find, and you are going to need ampere meter and then voltmeter. Of course, a power supply or a cell. You can use a power supply and a variable resistors for changing the current or the voltage. So these 5 components or devices you are going to need in this experiment. And the circuit diagram, generally these kinds of circuit diagrams are quite easy to draw or understand. The easiest way is you ignore, in a first instance, you just ignore the presence of voltmeter and join the rest of the 4 components in a closed loop. You can start from any of the component. So let's say I am starting from resistor. So this is my resistor connected with ampere meter, and then this ampere meter now is connected with a cell or maybe a power supply, and then connect this with a variable resistor, and then R. This is your R. And once you're done with the closed loop or a series connection, the last component is a voltmeter, and the voltmeter is connected parallel to the component which is being studied. In this experiment, we are studying R or resistor, so the voltmeter should be parallel to the resistor. That's how you draw your circuit diagram. Okay. Part B. The student uses a digital ammeter. State one advantage of using a digital ammeter rather than an analog ammeter. Clearly, in analog, if you have seen any analog meter contain a scale in which you have a needle that moves left or right, and we read reading from analog meter. So clearly, if we use analog meter, so we might have a parallax error. So digital ammeter remove the parallax error, and of course digital ammeter is more reliable than analog and more sensitive. So that's how you can differentiate between these two. The student takes appropriate reading with repeats to determine mean values. Explain an experimental technique she should use to ensure an accurate result. This is all about passing current from a circuit. So there is one important technique to improve the accuracy is, once we note down the reading from the voltmeter and ammeter, so we will have to note it down. So when you are noting down the reading in a notebook, so you should make sure that you turn off the switch so current does not pass from the circuit, because if you keep switch on and noting down the reading, in this interval current keeps passing from the circuit, that can cause increase in the temperature, so increase in the resistance. So in order to control the temperature, she should turn off the switch and then note down the reading. This is one of the technique. So you can write like that. Question number 7. A student is asked to investigate the relationship between stress and strain for copper. He is given a 2-meter length of copper wire and some 100 grams masses. He intends to draw a stress strain graph for the copper wire. Write a plan. Stress strain graph for the copper wire. Write a plan for the investigation. You should draw us of the apparatus to be used. Okay, this is all about finding the stress strain graph of a copper wire, and there is a typical diagram. You can use a horizontal plank in which you mention some U-shaped clip and a wire passing from a pulley. Okay. And then you can hang some weight, and you can mention here a ruler. So okay, first of all, I'm sorry about my drawing. My drawing is not good, but I will show. This is a typical diagram, but I will show you exact one, so you can draw the diagram like this. Part B, list any measuring instrument and apparatus needed that are not shown in the diagram. So one common answer for this is we don't mention micrometer screw gauge, but we use this instrument in our experiment. So any other measuring instrument is a micrometer screw gauge, and this device we use to measure the diameter of the wire. State the quantities to be measured. Of course, we are going to measure extension and diameter for the wire, area of the wire, and the mass that is hanged, or you can say it is a force. So extension diameter of the wire and the mass, and mass now can be converted into force. So these are the quantities we are going to measure during our investigation. Part D, state which of the dependent variable. Of course, mass is independent and extension is dependent variable. For two quantities, state in C, explain your choice of measuring instrument. So we are measuring extension and we are measuring diameter. So for extension, we are going to use a meter rule because of its precision, which is 0.1 centimeter, and appropriate for measurement of extension. And for diameter, we are going to use micrometer screw gauge because of the precision or resolution, which is 0.001 centimeter. So you can write for extension meter rule, and for diameter we are going to use micrometer, precision 0.001. For one quantity state in C, comments whether it's all about repeat reading. Yes, of course. Measurement of diameter we can repeat from various places and orientation, and we can use mean value to reduce random error or to get more reliable result. You also you can include more reliable result. Part G, explain how the measurement will be used to determine stress and strain, and include a sketch of the expected graph. In this investigation, we need stress sigma, which is force upon area, and we need stress. So delta L over L, and this force we are going to find after M multiplied by G, which is the weight. So stress is found after finding weight divided by the area, and epsilon, which is strain, and then we are going to measure this area can be measured as um, area can be measured as pi r square. This is area of cross section, or you can say pi d square by 4. And after finding stress and strain, you can draw a sketch. Stress on the y-axis, strain on the x-axis. We can expect a straight line passing through origin. That's how we can use our data set or our values in investigation. H, identify the main sources of uncertainty and or systematic error. Main sources of uncertainty, because we have extension measurement, which involves a parallax error in extension, and large uncertainty we can expect in the measurement of diameter, because of diameter is a very small measurement. So parallax, and in the diameter we have a small uncertainty. Due to a small measurement we have a large percentage uncertainty in the diameter. So these are main sources of uncertainty. Comment on safety, because we have a weight hanging on a wire, so we should be careful about the weight. The wire might snap or break, and the weight can fall on the foot, or maybe on floor. So we should place some foam, and also we should wear goggles to protect our eyes. So that's how you can write. This is all about hanging weight, and also you can include one more, wearing goggles to protect the eyes. Question number 8. A student carried out an experiment to determine the refractive index of glass. She measured the angle of incidence and the refraction for light entering a rectangular glass block. She recorded the results below. So this is the first column, incident angle, second column, refracted angle, and okay, criticize the result. Most common question in your unit 3, and less number of reading, sometime inconsistent significant figures, but we cannot use this. But repeated readings are not there, low range. So there are 3 or 4 typical points we can write. So in this case, the less number of reading, and only not 5, I'm sorry about that, there is only 4 reading, and no repeated values are shown. Okay, complete the table. So if you see, you need to complete this table, and this is sine of angle I and sine of angle R. Using your calculator, you can calculate sine of 10, sine of 20, sine of 30, 40, and then for the second column, refractance, sine of 7, 14, and sine of 20, and so on. If you do that, you have these values after completing. So part C, plot the graph of sine I on the y-axis against sine R on the x-axis on the grid provided, and draw a line of best fit. So this is the grid, and these are your values you need to plot. Remember, you need to choose a scale. This is, guys, this is the most important point. You need to choose a suitable scale so you can cover more than 50% region of your graph. So be careful about choosing your scale. So sin I on the y-axis, sin r on the x-axis, and I choose 0.1, 0.2, 0.3, and so on. So if you see these scale and these values for sin I, 0.17, and sin r 0.12, and if you uh, plot these 2 points on the graph, then you can get these points. So for sin r 0.12, you have 0.17, and so on, and line of best fit is this. Next, part D is use your graph to determine the refractive index of the glass. Again, a typical question, use your graph to determine the some quantity, and most of the time this quantity can be found using a gradient of the graph. For gradient of the graph, you need to choose a large triangle corresponding to 2 points, any 2 points of your choice, and from these points you can calculate the gradient to determine your required quantity. So I'm choosing these 2 points, this one and this one, and if you see from the graph the coordinate of these points, and or even you can mention the triangle like this. And then you can find the coordinate, and this is rise, this is run, dividing rise over run, you can find the gradient. So if you see, these are the point coordinate of the point, and if you do your calculation, so your gradient is y2 minus y1, so 0.6 minus 0.41 divided by no, I'm sorry, it's not 0.41, it is 0.2. Sorry about that. So y2 minus y1, so this is your y2, this is your y1, x2 and x1. So y2 minus y1, 0.6 minus 0.2 divided by x2 minus x1, so 0.41 minus 0.14. Once you do the calculation, you have gradient is equal to 1.48, and if you see the graph, this gradient is in fact sin I divided by sin R, which is a refractive index. So refractive index is your gradient, which is 1.48. E. Explain an experimental technique other than repeating reading that the student should use to ensure accurate result. This is all about reflection and refraction experiment. Generally, we use a bulb and we use a slit to get a small beam. If we need to improve our accuracy, so instead of a bulb, we should use a laser light, so a thin ray of light can be defined clearly. So a student should use laser light rather than a normal light bulb, so a ray can be defined clearly. Thank you very much. That's it for this paper. See you in the next paper. Have a nice time.